Alright guys, so this right here is graphing rational functions, and so this is really a big concept that you guys will see in the exam, in the quiz that you guys are going to see on Friday. I'm going to go ahead and go through it. That way you have a reference and you can get through the homework as well as the study guide and all those things. So just a summarization of all we've talked about for rational functions. So when I'm looking for x-intercepts, and I'm going to go through each one of these. I'm going to set the factors in the numerator equal to 0. Okay. When I want to find y-intercepts, I'm going to plug in a 0 for x. And when I'm finding, these are the big things, the vertical asymptotes and the wholes, well, that's when I'm looking at the denominator. If I have factors in the denominator that equal 0, that's where I find the vertical asymptote. But I have to look for wholes first. So if I have a similar factor in the numerator and denominator, well, that will cancel and create a whole, okay? So, excuse me. In class, guys, I did tell you to go ahead and change this problem, so I am changing the problem just so you can see here. And I'm going to go ahead and write this in factored form for the moment. Here we have okay, so we're gonna go ahead and find these characteristics before I move on to horizontal asymptotes and to slant asymptotes. So I do see that I have a similar factor in the numerator and in the denominator, so I do have a whole, and it happens at x minus 3 equals 0. So when I solve, it actually happens at x equals 3. Okay. I do see that I have something left in the denominator, x plus 1, so I am going to have a vertical asymptote, and it's going to be at x equals negative 1. Okay, and so the point of this is so that I can graph this, so I'm going to go ahead and start doing that. So I know I have vertical asymptote at x equals negative 1 right here. Okay. The x-intercepts. So again, guys, x-intercepts, you set the factors in the numerator equal to 0, so I already canceled out this one. I don't have this one in the numerator anymore, but I do have this factor and this factor right here. So I'm going to go ahead and set them equal to 0. So x is equal to 0. I don't have to do anything to that one. If I leave this as a point, well, I know the x is 0 and the y is also equal to 0 because x-intercepts the y is equal to 0. Okay. X plus 3 is equal to 0, so I solve. X is equal to negative 3, so when I make this a coordinate, I have a 0 at negative 3 and 0. So 1 to negative 3, and right here. Okay. Okay, guys, I don't know if you can hear snoring in the background. If you can, I'm sorry. It's my dog. She's in the background. She's asleep in her bed. To find the y-intercept, we're going to plug in a 0 for x. So what I mean by that, guys, what did I have left over here? So I had x and x plus 3 left, and on the denominator I had x plus 1 left. So I'm going to plug in zeros every time I see x. So 0 times 0 plus 3 and 0 plus 1, which is 0 times 3 up here in the top, and on the bottom 1. Well, what's 0 times 3? 0. 0 over 1 is just 0. So my y-intercept is 0, so I have the y-intercept at 0, 0 also. So I don't have to put anything here. It's already there, 0, 0. Okay? So what I'm going to evaluate next is, well, what's the highest degree here? I see the highest degree is 3, so I know my n is equal to 3. The highest degree I have here is 2, so my m is equal to 2. So when I'm looking over here, do I have one of these cases? Well, yeah, I have the third one. That means I have a slant asymptote. Okay, and the way I can find where that slant asymptote is happening is with what we call long division. Okay, so I'm going to go ahead and do the long division here. So x to the third, so x to the third, and I don't have an x squared term, so I do need to put that, minus 9x plus 0. Okay, and I'm going to divide it by what I have in the denominator, so x squared minus 2x minus 3. So I still see quite a few problems with this one, guys. I look at the coefficient here in the front. Here I have a 1, and out here I have a 1. So here 1 divided by 1 is 1x. Okay. Now what I'm going to do here is I'm going to multiply this 1x times every single one of these numbers. So when I do that, 1x times x squared is x cubed. 1x times 2x is negative 2x. 1x times negative 3 is negative 3x. And the only thing I have to do here is switch all the signs. So this goes away. 0 plus 2x is 2x. Negative 9 plus 3 is negative 6x, and the 0 will come down. Okay. So I'm going to do this again now. Now my coefficient is 2, and over here it's still 1. So 2 divided by 1 is 2. Okay. And guys, really at this point I can stop. I have a y-intercept at 2. I have a slope here, 1 over 1, so I'm going to go 1 over 1, 1 over 1, 1 over 1, 1 up to the side, 1 up, and 1 to the side. And so I start to develop this asymptote that looks like this. Okay. Now, let's go ahead and finish this off. So this will, I do have to go through that point, so I know my line has to do this. I know my line has to do this here, because it has to go through that point. So this is the way my graph looks. And I can't forget, I have a hole at x equals 3, so at x equals 1, 2, 3, come up to the graph, I do have a hole right there. So this is the final graph. This is what it looks like. And really, guys, I think this is the hardest thing we cover in this chapter. So if you have questions on this, please ask me. This is going to be on the exam. This will be on the quiz. So please study this.